Good morning, everyone. So I'm going to introduce Peter Levelt. She did her PhD in the physics department of the Free University of Amsterdam, and then started to work at KNMI, the Royal Netherlands Meteorological Institute, in 1993 to work with GOM and Schermaki instruments. In 1998, she became the PI of the OMI instrument, launched on the NASA Aurora satellite in 2004. And she has been responsible for the International Scientific Program of OMI. She's the scientific founder of the Dutch ESA TROPOMI satellite instrument launched in 2017 on the ESA EU Sentinel-5 precursor satellite. And since 2007, she is part-time professor in satellite observations in Eindhoven, and then switched to Delft Technical University. In October 2009, she became the head of the Climate Observations Department at KNMI and responsible for OMI and TROPOMI projects. She's also involved in various ESA programs for the EU Copernicus Sentinel-4 and 5 missions, and chaired the ESA Sentinel-5 precursor TROPOMI MAG. She also worked with the European Space Science Committee and the International Ozone Commission and the TNO Industry Advisory Board. And she's, since May 2016, also professor in the New East University of Nanjing, China, and studied the cooperation between KNMI and the New East Center. And since 2021, she is the director of the UCAR Atmospheric Chemistry Observation and Modeling Lab here at UCAR. And I think she will talk about future satellite mission for Africa.
Okay. I have to mute. Is this better? Yeah. Okay. Ben, thank you for the extensive introduction. And I'm very happy to be here at this UCAR Africa initiative, which is led by Wen Fu, and being able to talk a little bit about our new initiatives on satellite observations over the Global South. So, title is Investigating Expanding Air Pollution and Climate Change on the African Continent. And what you see here is an image of Top OMI. It's Top OMI nitrogen dioxide. It's an average over 2019. And you see Africa. You see red values, which are high nitrogen dioxide values. Tropospheric NO2 column. It's formally what you see here. And the blue are very low tropospheric NO2 values. So that's what you regularly see over ocean, because there are no emissions, except for ship emissions, of course. And those you also see in this image. The red values near Johannesburg, they are caused by a high field. Near Johannesburg, there are 12 power plants on this high field. And they are very, very polluting. The only country I've been in Africa has been South Africa. And I drove near Johannesburg, and it's unimaginable how much pollution there is. Then you see higher values due to cities, but you also see these three broad ranges, or basically two very broad ranges of higher nitrogen dioxide values. They are in yellow and green. They are caused by the biomass seasons in Africa. Since it's an average over 2019, you see all the seasons. So they go from sub-Sahara to the south in April, June, and October. And therefore you see higher values in those areas. Okay, so just want to tell you a little bit of when I became interested in Africa and why. And this was actually when I went to an inaugural address of Marleen Dekker. You see her name lower right. She works at the Africa Institute at the University in Leiden. And recently she also became director of that institute. So this institute does socioeconomic research in Africa. So it's about social factors like position of women, but also economic growth. And from her inaugural address, I understood that there would become a huge increase in population in Africa. And one we have never seen before, I think, on any of the other continents. And this was in 2016, so it was about a year before the launch of Trop-Omi, who was launched in October 2017. And I thought, okay, well, maybe we can do something with that, with the Trop-Omi data. Not only look at an increase on air quality, but maybe also, since these data will have such high spatial resolution, link it to socioeconomic research. And we know that we can see, for example, the rest day in a country. We have less nitrogen dioxide. So that's actually a social activity, which you see in our NO2 data. And there are more links you can think of in that context. And that time in Holland was very important to reach out across all science foci. So they really were interested in proposals where you link more beta, the hard science, to socioeconomic research. So what we did then, we wrote a proposal for the so-called Lawrence Center. Lawrence Center is at the University of Leiden, and you can have workshops there, week workshops, completely supported. But these are, you have two sizes, so about 20 people and about 50 people in a workshop like that. And we went for the 50 people workshop. We organized that. That proposal was awarded in 2020, but then of course we had COVID and the whole stuff. So in the end, our workshop was in 2022, in April in Leiden. And one of the things that they also provide is funding for people to come. So we had about 50% of the people in this workshop present in person came from Africa. And that was really, for that I also got a lot of help from Marleen, because we also reached out to socioeconomic research, because the African Institute, they fly, I think, before COVID and now after COVID again, almost every month to one of the countries in Africa. So we have a lot of connections on the ground, and that was also one of the ambitions, to really connect to the scientists in Africa. So that's how my interest started. Well, when I came to Anchor, I brought this subject with me, basically. It was part of my presentation for the selection. And I also negotiated to get 3-year funding for project scientists to work on this, and that became Wen Phu. And Wen Phu is great. We are very happy with her. And she initiated this PSIF effort, this PSIF UCAR broad initiative, to see what type of work do we actually do across UCAR on Africa. And that is actually a lot. So I'm not going to talk about this, but I just want to mention it. And that's also the reason why we have this seminar series now, and I'm one of the speakers for that UCAR PSAF initiative. Well, why did I bring it to ACOM? I think that we can really do a lot for Africa, because we have all this expertise. We have modeling expertise, we have aircraft expertise, we have chamber expertise. We have satellite observations, you work on data assimilation, we have ground-based monitoring. And for all this, there are needs in Africa. And to understand Africa, we probably need all this capability to get a step further. So I think it's really a good subject for a lab, because it will really be cross-section in the end. Okay, so I will shortly say something about this. So one of the things we work on is an aircraft campaign in East Africa. It's very challenging. So let me directly put that there. But still, there is a group, and you see this group of scientists actually as co-authors on this paper, this BEMS paper we just submitted, which is really working on that and interested in that. So Solomon Billing and William Visuet, they are the two leaders basically. And we are working on ideas to get an aircraft campaign there, but we also realized that we need more than only an aircraft campaign to make that effective. So this paper is quite broad. It talks about modeling and ground-based, in situ, the whole stuff, and also it talks a little bit about satellite. Then there will be, there is a campaign prepared currently by Great Britain. They wrote a proposal to NERC, and there is also an NSF NERC proposal that is currently written with the universities of the USA. We are not eligible as NCAR, but we can still support that. And one of the main things we will do is air quality forecast. And that's Rajesh and Ben Fu who will work on that with the Severi project, which Rajesh has. And then we had a workshop in September this year. And this was an NSF workshop in preparation for a so-called STC proposal. So that's a science technology proposal. So these are these big proposals from NSF to found a science technology center. And that will then be founded in North Carolina. So Solomon and William are the receivers of that if we are successful. And this is really, really challenging. So it will be a lot of work to get that on the level it has to be. So, and with all these people, we're also preparing and thinking about an aircraft campaign over East Africa, but not before 2030. That's our estimate. So the one from Great Britain will be around 2027. That's their aim. And also East Africa. And of course, with that experience, we can learn again. Okay, so I thought in 2016 about Africa and research over Africa, and more recently, I'm also thinking more and more about the geostationary satellite over Africa. And the first time I thought about that we really need that was maybe 2 or 3 years ago, and I was not the only one thinking about that. Already in 2015, there has been a paper written by Eloise Merre and Kelly Chance about the virtues of having a geostationary satellite on air quality above Africa. And so this was before the launch of TopOMI, so they use OMI data here to show what we then already could see over Africa. So, so Africa, I think the population increase there, it is expected to double in 2050 from now. So that's 30 years. 70 years from now, we go to 3.8 billion. That increase has never been before on Earth. So that's incredible. And at the same time, there is also an industrial revolution going on. So the economic value or a level of Africa is going up, but that usually means that you also have more pollutants. So there's a combined effect, basically. So when you look at Africa, and here we look at TopOMI data, it's an average over July 2019. We can measure nitrogen dioxide, and that's an indicator for fossil fuel burning. We measure CO, indicator for biomass burning. We measure formaldehyde, indicator for biogenic emissions, and we measure UV aerosol index, indicator for Sahara dust. So all these pollutants are there in Africa, and all of them we can already measure with satellites because TopOMI is not the only one flying over there. At the same time, there is a lack of ground-based measurements in Africa, huge lack. There's a lack of correct emission estimates in Africa. So there is really a need to improve our knowledge over Africa, especially when you consider this huge increase in air pollution and also greenhouse gases. So here you see a slide got from Solomon Billing And you see here the most of the world's fastest growing cities are in Asia and Africa. And I think in 10 or 20 years from now, they will be all in Africa. And also the 10 largest cities will be in Africa in 20 to 30 years from now. So that will be a big impact. Same time, there are not so many ground-based measurements. So you see here reliable ozone measurements globally. You see most of them are in the US, in Europe, Asia, and we barely have measurements in the global south. And also not above Africa. Also, this one shows that this is a slide made for the Maya satellites measuring aerosols, and you basically see the same situation. And there are aeronet measurements there, but if you compare that to the amount of measurements in Europe and the US, it's a completely different ballpark. So you might have one aeronet per country, basically, on the Africa continent, with the exception of South Africa. And at the same time, the continent is just like us, like the other continents. So also in Africa, there was COVID. So you see here tropomi NO2 measurements over Africa. You see the upper right is April 2022 over Nigeria. The lower right is April 2019, so the year before COVID in Nigeria. You see a clear reduction in the amount of nitrogen dioxide. One of the things that makes Africa really different from many of the other continents is the biomass burning. And you see here two sets of CO and NO2 measurements over Africa in the 3 biomass burning time periods over the year. So this is April 2020 average, June 2020 average, and then October 2020 average. And biomass burning is really big in Africa, and it's one of the reasons for that is that it's still used in the agriculture sequence to burn the fields after the crops have been delved. So this is really a big impact, and which will really change a lot of the air quality and pollution discussions and what we will find in Africa. Okay, so what did we do till now here at AECOM? We basically had 2 research initiatives, and one I came up with based on New York Times articles in November 2021. So there were 2 articles in sequence that were talking about the clean energy revolution and what that means for Africa. Because for the clean energy revolution, we need a lot of minerals. So the mineral mining in Africa is growing fast. And what you see here in the photo, for example, is a city in Africa. And the city is on the left and the mine is on the right. So this mine is as big as the city. And mining produces pollution, because most of the mining is for this cobalt copper is done using diesel machinery, not only to get the minerals out, but also to transport them. So, for example, the oil sands in Canada, we could see already in OMI measuring NO2 and even SO2 in that case. And the NO2 was also mainly caused by transport over these huge mining areas of the minerals. So I asked myself, can we see this in tropomi data? Can I see nitrogen dioxide on top of these mines? And turned out we can. So this is an image which we made after we did a lot of research. And I think it's the same city. And you clearly see that there is higher nitrogen dioxide over the mining area than over the city area. So the mine is on the left. So it's not the same city. And the city is on the right. So there's more pollution from the mine than from the city. And it's important that people are aware of that and the large pollution factor of this mining activity. So Sarah in our lab did a lot of research on this. and we have an accepted paper now in JGR. We looked at several mining in Congo area. You see the dots. Most of them are mines, not all. 2 are cities. And we studied 4 years. We took averages over these 4 years, so 2019, 20, 21, 22. And we also calculated emissions from these mines, and these emissions we could relate to production information we had from the mines. So how much cobalt, copper is produced, and is that aligned with the amount of pollution? So is an increase of pollution, does that relate to an increase of production? And that's the case. We could really show that. So yes, we can see these mining activities in our satellite data. Another initiative is from Wenfu. And that's what she did, is she put Musica on top of Africa. Musica is really a nice model. It's a global model, but it has this very high resolution capability, which you can focus, for example, on the US or Europe, but you can also do it over Africa. And that's what you see here. It's a very fancy grid. But the good thing of that is that your boundaries are well calculated, and you can also see in studies, for example, where the pollution goes from Africa and what type of pollution comes into Africa. So one of the things she did is she compared with all kinds of satellite data, Tropomi and MOPET-CO. And of course, there are a lot of differences between the Musica calculation and the satellite data, because that calculation is heavily dependent on the emissions. And the emission databases are far from perfect. So she saw a lot of differences, and the largest differences were actually in East Africa. So that's where we are. I mean, we are now discussing how we go further, what new research we will do in the next 1 to 2 years. Okay, we are not the only one looking at Africa. So I want to share two new papers from others. So this one is actually from my colleagues in the Netherlands, from Esron, together with a few Harvard co-authors. And it's talking about the monitoring of methane super-emitters using satellite data, and use basically Tropomi here, probably with some of the high-resolution images for methane which are now there. But when you want to have a global image, the only one who can give you that is Tropomi at the moment. And these colors indicate a lot, but I only want to talk about the purple colors over Africa, because those methane emissions, which were measured with Tropomi, it's unclear where they come from. So we don't know what produces this purple emissions. So these are unclassified, and most of them are in Africa. Another interesting paper is also from my colleagues from Esron. And what they did is they looked at CO, and then not for biomass burning, but for cities. And you see here a whole set of cities where they basically calculated CO emissions. They have a certain technique for that, which is called cross-sectional flux method, which actually was developed at Harvard. And then they started to compare that with 2 databases, the Dakiva database and UCAR database. Both are not perfect, and that is also what comes out. There are a lot of difference between the Tropomi CO emission estimates over a city and this UCAR and Dakiva databases. And the interesting thing is, it's not like I expected that basically this databases would be too low everywhere, but that's not the case. So they can be too low, they can be too high. And that's still a whole area of research, not clear why. And this is the method. I will not go into that now, but it's a very interesting method to calculate emissions. So when we looked at the satellite perspective, and what are we going to measure on air quality globally? You see below, you see all the operational sounders. So you see Sentinel-5P, which carries Tropomi. Sentinel-5 is the follow-on for Tropomi. And we will have 3 of those. So 30 years of measurements coming after Tropomi. OMPS from the United States. And then we have Amy, which is basically the sister of OMI, I would say, from China. And then we have 3 geostationaries planned for the northern part of the globe. So we have TEMPO launched, GEMS also launched by South Korea, and Sentinel-4 will be launched next year. So then we have the whole stuff covered up there. So one of the reasons why we have now more activity and I think a chance basically to catch a geo over the global south and hopefully over Africa is because the Vice President Kamala Harris, she visited NASA Goddard Space, I think about half a year ago, and they showed her this image. And then she said, where are the geos in the global south? And that led to a question to the National Space Council, where I gave a short presentation about this after that. And yeah, one of the things is that there has to come an answer. So Ball Aerospace is really interested in that. I will skip this one. I hope, yeah. And so they are working on this now. They reached out to us here in NCAR. And they are working on 2 geo initiatives over the global south. One is over Africa. And they appointed a science advisory board, which we are still gathering all the names. So this is just a start, which they asked me to lead. And then there is also a science advisory board for geo over the Middle East and the north part of Africa. And I'm a member of that science advisory board. So it's not like this will be really different from any of the other satellite instruments I was ever involved with, because the finance they will try to get from private or philanthropic or NGO type. So it's really a different route. Well, corporate is working on that, but it is challenging. You know, it can be successful, cannot be successful. In the Middle East, of course, there are very rich private funders. And they are talking to those people. Okay, what do we do further? At the HU this year, we will meet with a few leaders in the field, so NASA, NCAR, and anyone who's coming there. We will have papers at the HU. I have one, and Ball Aerospace has one on the Global South and Africa. We will have the OMI Science Team meeting here in June 2024. OMI will then be 20 years. So we also benefit from the extension of the EOS series. And I will try to make that open also for top OMI papers, for GEMS papers, for TEMPO papers, and we have a session on Africa. And then, now the letter I already told that they talk to private funders. So this is, the purple one is the one which TEMPO could reach to. And we would, of course, like to have a larger area. But when we would combine this with the Middle East one, we can maybe look a little bit lower. And then we have the Middle East, which also captures North Africa. And then we have whole Africa. Yeah, so this was my presentation. This is where we are. And I'm open for any questions.
So following your international meeting in Leiden, when you invited all these African scientists,
yeah,
did you get a lot of interest and take-up of African scientists using OMI data for their own research or their own applications?
I don't think so, actually. No. So that's not sufficient to workshop, and we didn't expect that also. So what we try to do now in Europe is to write proposals. We wrote a proposal to the EU, and we wrote a national proposal to continue with that research and to really to try to get African scientists in. I got some extra funding from KNMI and the University of Leiden to appoint someone who can really help with that effort and to write the proposals because, Marleen and I are too busy, so we need someone to help out. But that was not successful till now. And what is also really difficult is that since I'm now here, I cannot on some proposals I can still be leading because I still have 2 small affiliations at KNMI and TU Delft, but almost not. So that is also, which complicates a bit the continuation of that work. Yeah, but now I started here, and I hope we get a more European-US effort on this. But you have the Atlantic divide. And for cooperation, that is not always easy.
Yeah, maybe a simple question. What limits the range of those satellites? If they're geostationary, why don't they see?
Well, the geostationary, they move with Africa or Europe, and they move a bit, and they hang at 36,000 kilometers. Yeah. The polars are 700, 800 kilometers. So it is a combination of, the main thing is you have to get sufficient signal to noise. And the broader you look, the less you have. And it is determined with how accurate you will measure. Do you want to measure on 4x4 kilometers, 2x2, 10x10? Then it is dependent on what trace gases you want to measure. So if you want to have very good formaldehyde, then you will have a smaller field of view because it's very, very difficult to detect. So it really depends on what do you want to measure, what are exactly your requirements of the trace gas, how low amount do you still want to be able to measure. And that all determines, and money. How big is your telescope? Yeah. So it's a whole range of things that come in there.
You see the whole of Africa, so that's what we count.
Yes, but I always say to people, so with TROP-OMI and OMI, the NO2, the SO2, they're all in the UV-Vis wavelength range. So it's the range which you see with your eyes. So when you look outside, you see a cloud without issue, but you don't see the nitrogen dioxide. So the sensitivity difference between those two is huge. We need much more light to be able to measure it. Therefore, we cannot do the same as meteor or surface. No, it's impossible.
The main reason that is really, as Peter said, it's the cost, and it's the size of your arrays, of your detectors. I mean, you could, theoretically, you could easily have one that covers the whole hemisphere, but it's going to be either multiple arrays, or you're going to have to scan it all over the whole thing, and then that's cost. And a lot of these ideas, they're trying to recycle parts that they already have, so they're not going to have new arrays.
Yeah. In the end, it's all about money. Yeah. Okay.
So in one of your early slides, you show how ACOM is best suited for these type of research because we have all the expertise, and you show a lot of achievement from modeling and remote sensing. So one maybe comment I have is from, for example, the lab perspective, or maybe from chemical mechanism perspective, how do we connect to this research? So I think one thing that might be useful for us from you is if model or satellite see any like outstanding precursor for pollutants, or if there are any chemical regime that are pretty unique to Africa, and maybe that will be a good opportunity for lab studies to dive deep into,
Yeah, no, I think it's excellent idea, Ching, and that's what I really hope for, that you get to that, because I think the chamber experiments can really try to understand different chemical mechanisms, which I expect to find there.
Yeah.
And then you also have Keko. And
yeah.
No.
We have models here too, but connect to, for example, if modelers see or remote sensing in situ measurements see some very interesting precursors or VOCs, whatever that might cause air pollution, then we can do a mechanistic study.
I completely agree to that. Yeah, so that's the direction we have to go. But I started with this because these are the measurements and modeling capability we currently have over Africa. We have to define the areas which are puzzling, we don't fully understand. Maybe we can go there already with count-based measurements. That's basically described in that BAMS paper. If you have some of that, then I think we can go to chamber and Keko to find out what is really going on there. That was, but we can talk further about that. Yeah, I really like that.
Maybe on what David was asking with his first question about engaging scientists in Africa, are there sort of parallel efforts to like build ground-based measurement infrastructure there? So I definitely, you hear so much more about colonial science, right? Or just like dropping in and doing something and leaving. And I think, we kind of have to go beyond that. So I'm curious about just like efforts to do parallel to build instrument networks there and train scientists and leave that's happening.
No, I completely agree to that. So in our workshop, we actually had people from the, what is it called again? AQ, they have this sensors for aerosols. ERCO.
Okay.
It's quite widespread in Uganda and Kenya, I think. We had people from those networks in the workshop, and they were really good. They used all kinds of machine learning techniques, and so these are still on the list of names we want to connect to. Then one of the workshops which Solomon initiated was in Kigali. And several people of our lab went there, also from RAL. So also there we have now people we know on the ground, so to speak, in our field. So when you look at the STC proposal, that is also really the ambition to really connect to African scientists and get them involved. So one of the things I'm thinking about is that we might be able to develop, as a result of this PSAF, which David is leading, the satellite one, develop a 1 or 2 week kind of education for how to use satellite data, because it's not easy to use this data. You really need to know what you do. It's not only useful for the USA, also useful for scientists in Africa. So we are really trying to connect to scientists on the ground. And that's also the reason why we are very interested still in this NERC-NSF proposal, because that in 2027, that would give us already a chance to also connect to African scientists. And also on this Geo Science Advisory Board, we already have 2 from Africa, and we want to extend that. Yeah. But it's challenging. It will need a lot of attention.
Yeah, nice presentation and overview. So I have a question about the potential East Africa campaign in the future. Would it be only for air quality, or there will be more than that, like the meteorology interaction aspect?
Good question. Might be very interesting, actually. So we are also preparing a campaign over Atlanta. It's called CNIX. And there we already want to reach out largely to meteorology and boundary layer, and for co-leads with the meteorology background. So maybe we could use that, because the meteorology will have a huge impact. Yeah, that's a good idea. Yeah. Thank you.
Yeah, I don't get any questions online. Let's thank our speaker again.